So the customer asked for constant pressure and a changing barrel length, what the exit velocity is. And so our whole project is trying to get a linear function to actually model the drop off of velocity with the extending length of the barrel. So we've got a 5.5 foot barrel or tank for this. It's 4-inch diameter PVC pipe. And is pressure rated for 220 psi, and then that gets throttled down to a 1-inch PVC pipe, which continues all the way to the barrel. We have 2 separate pressure gauges right now. Might turn into one, we will see. And so this is actually the Schrader valve that we put our pressure into right here, and then it travels along into the barrel. And then we've got our valve right here, and when it's perpendicular, that means it's closed, and that holds all that pressure back in there. And then when we reload, we just take the barrel off, and then you can see the projectile sits flush with this right here, or with the PVC pipe cut. We just put it in, strap it down, and then the barrel length and everything. And then right here, we have our circuit that will, when the ball travels through, it'll break each laser, and then we'll be able to get our velocity from the projectile. And most of these are threaded. Here and here, and then all of these right here are all threaded. And this one right here is especially threaded just because it throttles down a lot. And then we have cradles on this, is it a 2x6?
This one's a 2x4.
Oh, 2x4 right here. And then some 3D printed cradles that hold our launcher in place so it doesn't move when we actually launch it. And also some bigger ones back here for the tank that we have.
And it's all sitting on some sawhorses.
Oh yeah.
Yep.
This setup measures the velocity of a ball using 3 optical detectors coaxially aligned about the barrel with 2 inches between each detector. Each detector consists of a photodiode paired with a transimpedance amplifier built around a quad op-amp. The photodiode current is converted to a voltage across a resistor, and high-frequency noise is attenuated by a custom RC low-pass filter. Resistors are chosen based on the measured current through each photodiode when exposed to direct light. The relative spectral sensitivity of each photodiode is sufficiently high at 72%. As the ball passes each detector, it breaks the laser beam, causing a voltage drop across the amplifier. All detectors are measured simultaneously at 100 kHz by the data acquisition module. Assuming no air resistance, with a barrel length of 8 feet at 120 psi, this sample rate ensures, at worst, 6 samples between each detector. In reality, the instrument resolution will be much higher. Further testing will determine whether a closed-form quadratic solution for acceleration across the detector span will be sufficient, or if air compressibility will require a numerical solution. Sources of bias error include photodiode bias drift and amplifier offset voltage, both corrected by initial measurements. Laser alignment error, which shifts the trigger timing. Linear offset uncertainty will be accounted for through caliper measurements. Current from ambient light, which will be corrected by covering the detector in a black box. Precision error will come primarily from DAQ timing precision, limited by the 100 kHz sample rate. Repeated trials will be averaged to reduce random uncertainty.
We have multiple sources of error in our mechanical parts of the launcher. Here's a quick overview of some of the ones we have found and whether they are bias or precision error, and an estimate of what the value of that will be. In total, from an uncertainty propagation, we estimate around 13% of the total reading of error, and that's just coming from the mechanical parts of the launcher. Here are some assumptions we have made in our modeling of the launcher. First off, atmospheric and ambient temperature should remain constant, and the system should be adiabatic, and air should be an ideal gas. We have some gaps in our experiment currently that we are working on finalizing, such as the mathematical model, many error sources and the value of those error sources. Some parts of the launcher are currently manually operated, and we hope to automate those to reduce the amount of error. And finally, we have not figured out PPE to create a safer test environment. All right, we're gonna fire in 3, 2, 1.